This lesson corresponds with Roman numeral 4 in the Unit 8 notes packet, calculating empirical formulas and molecular formulas. Today specifically we're going to start with empirical formulas. An empirical formula is a formula that represents the lowest ratio of moles in a compound. There are some steps to solving an empirical formula problem. At first it's going to seem pretty complicated, but once we've worked through a few problems, it will make sense. The first thing we need to do is find the number of moles of each type of atom. You can use your mole map to convert from grams. Then you must divide each number of moles over the smallest one. If there's only 2, you just divide the largest by the smallest. If there's more than 2, you divide each one by the smallest. If the answer when you divide is a whole number, put it over 1. If it is not, still put it over 1 and multiply the top and bottom by the same number to get a whole number on both top and bottom. Finally, step 4. Use the number associated with each atom in the ratio to write your empirical formula. Let's try an example. What is the empirical formula of a compound that is 25.9% nitrogen and 74.1% oxygen? We'll start with step 1. Find the number of moles of each type of atom, and we'll use our mole map. Now remember that percentage is a ratio of the mass in a formula. So since we have percentages, we can automatically just say it's the same as the grams. So on this first one, I'm starting with 25.9 grams of nitrogen, 74.1 grams of oxygen. Using my mole map, I go from grams to moles. 25.9 grams for nitrogen times 1 mole over the GFM of nitrogen, which is 14.0. Do my division and I end up with 1.85 moles. For oxygen, I'm going to use my GFM of 16.0 grams and end up with 4.63 moles. Moving on to step 2. Take my larger number of moles, 4.63, divided by my smaller number of moles, 1.85. The answer that I get is 2.5. This leads me to the next step. If the answer was a whole number, I'd put it over 1. 2.5 is not a whole number, but I'm still going to put it over 1 and multiply the top and the bottom by the same number to get a whole number on top and bottom. Now since I'm dealing with 2.5, it's the decimal portion that I'm going to look at. 0.5 is the same as a half. If I multiply a half by 2, that's going to give me a whole number. In this case, I'm going to multiply by 2 on the top, 2 on the bottom. 2.5 over 1 times 2 over 2 gives me the equivalent fraction of 5 over 2. Now I know that the 5 is associated with the oxygen because remember that oxygen was 4.63 moles when I divided and used my mole map. And the 2 is associated with the nitrogen because the nitrogen was 1.85 moles when I used my mole map to go from grams to moles. So I'm going to use those numbers in the ratio to write my empirical formula. I have N2O5, and again that comes from this 5 over 2. 5 oxygens with 2 nitrogens. I wrote it as the nitrogen being first just because it was given to me first in the problem. Here's the next problem. If you're feeling pretty comfortable, I suggest you pause and try it on your own first. Start by converting mass into moles. 29 grams times 1 mole over the GFM of silver, 107.9, gives 0.269. 4.30 grams times the GFM, 1 mole over 32.1, gives 0.134. Remember, the next step is to take the larger number divided by the smaller. Silver is larger 0.269 over sulfur's smaller number of moles, 0.134, equals 2. This time we have a whole number. I put it over 1. And I can just use those numbers directly. Ag2S. Here's a third example using percentages again. Remember, percentage can easily be converted right into a gram. I would suggest you try this by pausing and then check. Sodium has a GFM of 23. Chromium's GFM is 52. Oxygen's GFM is 16. This time, I actually have 3 elements. Recall from the directions said to put the largest over the smallest and the medium over the smallest. Well, even though they're slightly different, when you divide 0.765 by 0.763, you get approximately 1. Putting the 0.763 on the bottom of 2.67, it comes out to a 3.5. Put that number over 1. Again, the 0.5 represents a half, so I'm going to multiply by 2 over 2. I get 7 over 2. Now notice, since I had to multiply by 2 over 2 on this one, I also went ahead and put the 1 over a 1, multiplied by 2 over 2, just to remind myself that this top one has to change to a 2 along with the bottom one. And the bottom one in both cases is chromium. The top one up here was sodium. The 7 represents the oxygen. Na2, Cr2, O7, sodium dichromate.